We've been working with vectors here for several lessons now, but we haven't been following the admonition I made back in the last chapter, which is to use functions as often as you can. So now's a good time to see how we can use vectors both as function parameters and as function arguments. So let's begin by looking at the program you have in front of you. I have a vector called grades. I have a variable for total. Then I have 5 grades added to the vector. What we want to do is write a function that will return the total of the elements in the vector. So we start out by deciding the return type of the function. It's going to be int. We're going to call this function SumVector, not SumGrades, because we could use it with any vector. Then the parameter for this function will be just any vector. I don't really mean any vector because it has to be an integer vector. And then a name following that data type. Just call it vect, for example. Any name will do here. It's just like a variable name. Open the function body. We need a variable to store the total. We'll initialize it to 0. Then we just write a loop to loop through the vector and add the elements to total. Just like we've done many other times. In fact, we've done this so many times we can practically do it in our sleep. And then the body of the for loop is just total plus equal vect sub I. Add a return statement to return the total from the function. Now we can move down to the main program. Call the function by assigning its return value to the total variable, and for the argument we just use the vector name. Let's write out the result. Put a new line there. Build and run the program. And we see the total is 439. And that's right. So look at the function definition again, and let's pay just a little bit of attention to the parameter. When you use a vector as a parameter, you have to use the keyword vector, the data type of the vector you're calling, and then a name for a vector that's going to be replaced by the argument name in the calling program. Other than that, it looks just like any other function that you create. So let's look at another example. Besides totaling the elements, we might also want to display the elements of the vector. We might want to do that by writing out each vector element to the console. So we'll do that by creating a void function, since we're going to write out the contents to the console in the body of the function. There won't be a return value, so it's a void function. And we'll call this function display vector. The same type of parameter that we used before. In this case, all we need is the loop that loops through each vector element, using size again, plus I. And then cout vect sub I. And then let's put a space between each element. And that's all we need. So we close off the function body, move down to the main program. Let's add a new line. Well, we already have a new line. Let's have a heading here. The grades are, followed by a new line, followed by a call to the function, display vector grades. And then let's put another new line at the end. So build and run the program. And there we go. We might have chosen to put each vector element on its own line, but this saves a little bit of space that way, and for a long vector or large vector, that would take up a lot of screen space to do that. So we've seen 2 examples of functions that work with the contents of a vector. Let's look at one more function that this time modifies the elements of the vector. Since we're working with grades, we'll stay in that area, and one thing we might want to do to a set of grades is curve them. So let's write a function called curveGrades. It will be a void function also. This time we will call it curveGrades because that's all it's going to do. It wouldn't make sense to write curveVector because that doesn't really mean anything. Again, for the parameter, we're going to specify a vector, but this time we need to specify the vector as a reference rather than by value, because we're modifying the contents of the parameter. In this case, the contents of the vector that's being passed in. So we have to pass the vector by reference to the function. Inside the function itself, once again, we loop through each element. So we know how to do that. And then for each element, we want to add some amount. So in fact, rather than just pick an amount arbitrarily, let's add a parameter for that. So go back to the parameter list and put a comma after @vect and add int amount. So now go back to the body of the loop and write vect sub I plus equal amount. And that's all we have to do. So when we call the function, we'll pass in a vector and the amount that we want to curve each grade by, and that will perform the task. Let's go down to the main program, drop down to the next new line, and let's call the function curveGrades, with grades as the vector and 5 as the amount. And then to see if our function worked, we can call displayVector with grades again to see. Let's add an inline at the end. Let's build and run the program. Okay, and there we see that at first the vector was 84, 77, 92, 98, 88. And then after we curve the grades, we have 89, 82, 97, 103, and 93. The key to curveGrades is being sure that you pass the vector in by reference. If you pass it by value, then it won't make any changes to the vector in the main program. It would change the vector in the function call itself, but when control goes back to the main program, then the values in the vector would stay the same as they were before the function was called. Now that we know how to use vectors with functions, we can move on to some more complex operations on functions such as searching and sorting. But before we do that, I want to take a small diversion and talk about generating random numbers and storing them in vectors. When we get to sorting and searching, we're going to want to work with large data sets, hundreds and even thousands of vector values. And it's just too hard to come up with numbers yourself for those vectors. It's a lot easier to generate random numbers within a range, say 1 to 100 or 1 to 1,000, and then use those random numbers to see if your searching and sorting functions work correctly. So in the next video, I'll demonstrate how to generate random numbers and store them in a vector.